Assalamualaikum and hi everyone. Okay, so welcome back to my class. Okay, on our previous class we already talked about the integration. I already introduced to you on how to do integration by using a few different methods. Okay, so firstly you need to remember about your integration rules. Okay, so we already made a long list of the integration rule that you need to memorize because it will not be provided in the exam paper. Okay, secondly, we already learned about two different types of integration. One is definite, another one is indefinite. Okay, so definite or indefinite. Okay, where in the definite integrals you will be given two different values and you need to evaluate the values into the integration, the product of your integration, and from the definite integrals you will end up with a number. Okay, it could be any number, it could be a whole number, or it could be a fraction, or even a decimal numbers. Okay, secondly, there will be indefinite integrals. Okay, integral products. Okay, where these integral products, okay, will be living as x in the terms of x or in the terms of y depending on the given function plus c, where the c is a constant. Okay, so we don't need to find out what is your c, we just leave it as the constant c. Okay, so everyone acknowledge that when you have c, that means it should be a constant. Okay, so that is indefinite integrals. Okay, your final answers is in the terms of x or in the terms of y. Okay, so there are different types of how you can do your integration. Okay, so either you are using integration by using formula or rules or formula. Okay, and then you can do integration by part. Okay, as well as by doing integration by substitution. Okay, so these are the three different methods on how you can integrate a function. Okay, alright, so today our focus is only to do first part of the application of integration, which is area under the curve. Okay, so you're going to find out area bounded by the curves given in the integral function in the question. Okay, so application of integration is divided by two parts. Okay, so the first one is area and the second one is volume. Okay, so in this video we're only just focusing on the area. Okay, so area, we will come to several types of questions regarding the area in the integration. Okay, so the first one, that is the basic one that everyone needs to know. Okay, which is you have to find out the area under the curve. Okay, so there are two possibilities. Either the curve is on the x-axis or the curve is on the y-axis. So that comes to the second one, which is area between the curve and the x-axis or area between the curve and the y-axis. And when it comes to a more complicated questions, they might give you two different functions. Okay, so you need to find out the area between the two. So normally I will address this one as the combination area. Okay, so combination area. Alright, so let's look at the general formulas for you to remember about how to calculate the area between the curve. Okay, so in this first example, I have here, okay, so this is your y-axis and this is your x-axis. Okay, so as you can see, this curve we have y equals to fx, so that is the general function of the curve. Okay, and we are looking for the area between the y function with the x-axis. Okay, so there are 2 points here. One is at A and another one is at B. So A and B is actually the x coordinate, and values of B, we refer it as the upper limit. Okay, values at A, we name it as lower limit. Why does it lower? Because it should have a smaller values compared to your B. Okay, so how are we going to find out what is the area under the curve? Okay, between this curve and this x-axis. So area okay, equals to integrals from the upper limit of b and lower limit of a and function y dx. Okay, so you're going to replace this y, okay, according to the given function. Okay, so this is between the curve and the x-axis. Okay, so you might come to different types, okay, another type, which is between the curve and the y-axis. Okay, so this is the curve, okay, but now we are looking for the area between this curve and the y-axis. So this is your y-axis, okay. So this shaded area we are looking for, what is the value? Okay, so again we have this b and a. Again, your b is your upper limit and your a is the lower limit. Okay, so if they give you y equals to fx, this is the given function. Okay, so this fx is in the terms of x. Okay, so in order for you to find this area, you need to convert, you need to find out what is your x in the terms of fy. What is the new function? Because we're going to substitute area equals to b a, alright, x dy. Okay, which is your x is b a fy dy. Okay, so this area is a definite integrals. Why? Because they give you two different values for you to evaluate, and final answer should be living in the unit, okay, in the numbers, and the unit is unit square. Okay, so what if we come out to a combination area? Okay, so there are two possibilities, okay, for the combination area. First one is using one function, only one function, but we have one of the shaded region is at the upper regions of the x-axis, okay, and another one, okay, from here, as you can see, this shaded region is below the x-axis. So if we are looking for the total area, okay, so we need to find out what is the area. We label it, okay, let's label it, okay, so let's label this one as area A and this one as area B. Okay, so total area equals to area A plus area B. Okay, so your area A is integrals between b, a, and then your function fx dx, whereas your area B is from your upper limit is c, lower limit is b, and fx dx as well. Okay, okay. From here, okay, you can see that the area between the boundary b and c is below the x-axis. Okay, so when you calculate, okay, so this part, which is integral cb fx dx, okay, you will get a negative values. Okay, negative values because it is, okay, because the area is below the x-axis. Okay, so when we are calculating the total area, okay, in this one, we will ignore the negative sign. Okay, so total area, just take the values. Okay, we're going to ignore the negative sign. Okay, so whatever the value that you get here, let's say, okay, for example, if you get it as 14 unit square, negative 14, and this one you get it as 6 unit square. Okay, so sum of the area equals to 6 plus 14, which is 20 unit square. Okay, so this negative sign we're going to ignore because it's just to show the position of the shaded region. Okay, either it is above the axis or the below the axis. Okay, whenever you are calculating area and you find out the final answers is a negative, it's actually referring to the shaded area. Okay, the region that you are looking for is below the axis. Either it's below x-axis or below y-axis. So leave your final answers in the positive values. Okay, so once you finish your calculation, your answers is a negative square unit. Okay, write down it again, the final answers, which is area actually equals to positive, what is the values and the unit square. Okay, because area is not a vector quantity, it should be a positive values at all the time. It's a scalar quantity. Okay, so that is the first one. When combination area is just belongs to the same function. Okay, so we're going to do summing up all the area, okay, using the integration. Okay, but you might come to another examples, which is to calculate the area between two curves. So this area between two curves means you will be given two different functions. Okay, from the pictures given here, you have y1 equals to gx, okay, and y2 equals to fx. Okay, so what is the area of the shaded region here, A? So what is the area? Okay, so for this one, okay, the area of the shaded region should be equivalent to area equals to from the upper limit B and lower limit A. Okay, so y1, okay, minus y2, okay, dx. Okay, so which is y1 and which is y2? Okay, so look at which equation is at a bigger at facing upwards. Okay, so like this. So this one should be your y1. This one, okay, should be your y2. Okay, so A equals to integral BA fx, okay, minus gx dx. Okay, but if let's say you are confusing, okay, you are labeling the wrong y1 and y2, that's okay. You will still get the same answers. It's just either you will get a positive area or a negative area. Okay, that doesn't matter, because on your final answers you should state that it's a positive area. Okay, okay, so this one, area of the shaded region between these two curves gx and fx is BA, okay, from the upper limit B and lower limit A, fx minus gx dx. So whatever the given function, okay, so you have to integrate and then you minus the fx, okay, gx from the fx, and then you get the final answers by substituting the x with B and then with A as well. Okay, so again, the area should be in the unit square. Okay, alright, so let's look for an exercise, okay, to enhance your understanding. Okay, so let's look at this example 1. You find the area enclosed between the curve y equals to x, x minus 1, x minus 2, and the x-axis. Okay, so this question is very easy, very simple. Why do I say so? Because they already simplify the equation into its factorization form. Okay, so you can from this equation you can directly determine what is the x-intercept, okay, of the curve. Okay, so how do we determine the x-intercept? So y equals to 0, which is equals to x, x minus 1, x minus 2. Okay, so normally I will summarize the steps to solve this question by looking at this flow diagram. Okay, so first step, you need to find out what is the x-intercept. Okay, why I say it's x-intercept? Because the area that we are looking for is between the curve and the x-axis, so that's why we need to look for the x-intercept. Okay, so then we need to sketch the curve because we want to find out what is the region of the area that we are looking for. Okay, then from the information that we obtain from the first step, okay, we can label the x-intercept. Okay, because this x-intercept is compulsory, as it will set as the limit, okay, the boundary limit for your integral, either which one will be the upper limits and which of the x-intercept will become the lower limit. So that's why it's very important for you to label the x-intercept. Okay, and then we will label the required region that we will be looking for its area, and calculate the area of the required region, the total area. Okay, so let's find out the x-intercept. Okay, so when we are looking for the x-intercept, we just need to equalize this y equals to 0. Okay, so from here, since it's already written in the factorization form, so you have here x equals to 0, x minus 1 equals to 0, so your x will be equals to 1, x minus 2 equals to 0, so therefore your x equals to 2. So your x-intercept is x equal to 0, x equals to 1, and x equals to 2. There are 3 x-intercept. Okay, so if we expanding this y function is actually equivalent to a cubic function, okay, which is x cubed. Okay, if you expand, try to expand it by yourself, you'll get x cubed minus 3x squared, okay, plus 2x. So this is actually the expanded form of this function, which is a cubic function. Okay, so a cubic function, and it's a positive sign, so we'll have a positive cubic graph. Okay, then let's draw the graph. So this is your y-axis, this is your x-axis. Okay, so it have 3 different x-intercept. Okay, so which is at x equals to 0, so this is 0, and then this is 1, and this is 2. Okay, so the area enclosed between the curve and the x-axis is this part. Okay, so this is the first area, and this is the second area. So we have this one is like a combination area, so you need to find out what is this area A and what is the area B, and the total area, okay, equals to area of A plus B. Okay, so next, okay, once we already sketched the curve, label the x-intercept, we already labeled the required region, then we can proceed to calculate the area of the required region. Okay, so the first one for area A, okay, the upper limit is the bigger x coordinate, which is 1, from 1, and the lower limit is the x-intercept at the lower value than 1, which is 0. Okay, so your function, okay, originally they give you in the simplified version, which is in the factorized form. Okay, then I convert it into the expanded form. So when you are integrating, when you are going to calculate the area, use the expanded version. Okay, so x cubed minus 3x squared plus 2x dx. Okay, so integrate x cubed minus 3x squared plus 2x dx. Okay, it's using square bracket, so this one will become 1 over 4 x to the power of 4 minus, okay, so 3x cubed over 3 plus 2x squared over 2. Then close the bracket, and between 1, 0. So that means you're going to substitute all these x values with first 1 when x equals to 1, and then next when x equals to 0. So if you substitute when your x equals to 1, you will get the answers as 1 over 4. Okay, and then this one, when you substitute your x with 0, is equals to 0. So it's minus 0. So in total, you will get it as 1 over 4 unit square. So this area A is equals to 1 over 4 unit square. Okay, so then we only calculate area A. So we need to calculate the area for the region B, okay, which is your area B. Okay, so it will have the same function, but the upper limit now is not 1, but it is 2, and your lower limit is 1. Okay, so x cubed minus 3x squared plus 2x dx. Okay, so you integrate the function. So 1 over 4 x4 minus 3x cubed over 3 plus 2x squared over 2, and then close the bracket between 2 to 1. So you have to find out what is the area's value when your x equals to 2, okay, and when your x equals to 1. Okay, so when your x equals to 2, it's equivalent to 0, and when your x equals to 1, it's equivalent to 1 over 4. Okay, so values of area for upper limit must be minus with the values of the x when it's a lower limit. Okay, so this one you will get a negative 1 over 4 unit square. Okay, negative sign, so don't be panic because the negative sign here, okay, the negative sign here actually is referring to that the area, okay, the area is below the x-axis. Okay, so that's why you get a negative sign. Okay, negative because the area is below the x-axis. Okay, which is correct because this region is below the x-axis. So how do you find out what is the total area? Okay, so total area equals to A plus B. So your A is 1 over 4 plus your B is 1 over 4 unit square 2. Okay, so ignore the sign, which is in total you will get 2 over 4, which is can be simplified into 1 over 2 unit square. So this is the total area. Okay, so that is the final answers. 1 over 2 unit square. Okay, let's move to the next example. Okay, so now you were given y equals to x 4 minus x squared. Okay, so first step we need to find out what is our x-intercept. Okay, so again let your y equals to 0. So from here we'll get x equals to 0, and then 4 minus x squared equals to 0. 4 equals to x squared. Okay, so x squared means you will have two different values of x. Okay, so plus minus 2. Okay, so therefore your x-intercept, we have 3, which is at x equals 0, x equals to negative 2, and at x equals to positive 2. Okay, so if we expand this function, okay, we expand, this one will equals to y equals to 4x minus x cubed. So it's a cubic function as well. Okay, but now your cubic function is a negative. So if it's a positive, it will going upwards like this. Okay, so this is a positive cubic function, and if it's negative, it's going downwards. Okay, so this is a negative cubic function. Okay, so next we have to sketch the curve. Okay, sketch the curve. Okay, so our x-intercept is at 3 different values, which is negative 2, negative 2. Okay, so the first one is negative 2, 0, and positive 2. Okay, so that means this is your y-axis and this is your x. Okay, so next we have to label the required region. So the required region is this one. Okay, area A. So we label it as A, which is below the x-axis. And then area B, okay, which is above the x-axis. So we're going to expect this A to be a negative. Okay, from our calculation, this one should be a positive. Okay, so let's calculate the area. Okay, so your area A equals to, okay, from the upper limit 0 to negative 2, okay, and then the expanded function, which is 4x minus x cubed dx, which is equals to, okay, 4x squared over 2 minus x to the power of 4 over 4 between 0 to negative 2. Okay, so you need to find out what is the values of the area when your x equals to 0, okay, and then when your x equals to negative 2. Okay, so just press your calculator. Okay, so when it's equals to 0, okay, you will get it as to be 0, and when your x equals to negative 2, you get your answers as 4. Okay, so 0 minus 4, which is negative 4 unit square. Okay, so your area A is actually 4 unit square. Okay, so next we're going to find out your area B. Okay, so area B is between upper limits of 2 and 0 for the same function. Okay, expand for integrate minus x to the power of 4 over 4 between 2 and 0. Okay, so when your x equals to 2, okay, so your area will becomes 4. When your x equals to 0, it's equals to 0. Then we minus, so we get as 4 unit square. Okay, so your region B is 4 unit square. It's positive because the area is above the x-axis. For your A, okay, it's a negative. We get negative from the definite integrals because the area is below the x-axis. Okay, but we are more looking forward towards calculating the total area. Okay, so total area means you have to add up area A for region A plus area for region B. Okay, when we calculate the total area, we ignore the sign. So this one is 4 unit square plus 4 unit square. So in total, in this function, okay, the area enclosed between the curve and the x-axis is 8 unit square. Okay, so that two different examples is we're looking for the area enclosed between the curve and the x-axis. Okay, so we're going to move to a third example, where in this third example, we're going to find out the area enclosed between the curve and the y-axis. Okay, so generally, okay, when we come up to this one, okay, we have the general formula, which is area equals to from upper limit to a lower limit, and this one should be x dy. Okay, so that means they give you y equals to ln x. Okay, so you need to find out what is your this function in the terms of x. Okay, so y equals to ln x. If we want to convert this ln x into x, we need to remove this ln. So how to remove ln? By multiplying ln x with e, exponent. So it becomes exponent ey equals to e ln x. Okay, so when e meet lns, okay, exponent meets lns, it will become 1. So at the end, we have e exponent to the power of y equals to x. So this is the new function, okay, which we can substitute into the general formula in order for us to calculate the area bounded by the curve with the y-axis and the line y equals to 4. Okay, so we have to sketch the curve first in order for you to get a better idea where is the region that we are looking for. Okay, so if it's a ln function, okay, so ln function will looks like this. Okay, so it will pass through x equals to 1. Okay, so this is y equals to ln x. Okay, then line, the question asks you to calculate the area bounded by the curve y equals to ln x, the y-axis, and the line y equals to 4. Okay, so let's say this is your y equals to 4. So the area that we are looking for is this, okay, between y equals to 4 and y equals to 0. Okay, so that is the area. Okay, so how to solve this one? Okay, so the area equals to, okay, your upper limit is the biggest y number that we already labeled in the graph, so 4, and the lower limit is 0. Okay, and then x dy. Okay, so just now we already convert your y, okay, y equals to ln x into a function in the terms of x. Okay, so x equals to ey, so it's ey and dy. dy. Okay, because we have here y not x, so that's why it's dy. Okay, integrating ey, we'll get the same thing, which is ey as well. Okay, so e to the power of y from 4 to 0. Okay, so when your y equals to 4, it is e to the power of 4. Okay, and then when your y equals to 0, it becomes e to the power of 0. And as we all know, e to the power of 0 is actually 1. Okay, so we can simplify our answers as e to the power of 4 minus 1 unit square. Okay, you can also calculate by using calculator. Okay, converting it into a real decimal numbers. Okay, e to the power of 4 minus 1, which is equivalent to 53.598 units square. So that is the answers. Okay, so I have another 2 examples. Okay, so this time around, these final 2 examples will be a combination types of area. Okay, a combination area. Okay, so the first one you have here, find the area bounded between the 2 different curves. Okay, y equals to x minus x square, and another one is a linear line of y equals to x minus 1. Okay, if you if you meet this kind of question, okay, where you will need to calculate the area between 2 different functions, between either one is a curve, another one is a linear function, or both function is a curve. Okay, so you can follow these 5 simple steps for you to solve the question. Okay, what is the 5 steps that I mentioned just now? So the first one, you need to find out what is the intersection points between the 2 curves. So how do we determine the intersection points between these 2 curves? We're going to equalize both of the function. Okay, so this one, equalize. So that means we have first y equals to y1 equals to y2, where your y1 equals to x minus x squared and your y2 equals to x minus 1. So we have to find out what is the values of x from here. Okay, so 0, let this be 0. This x squared will be transferred to the right side, so it become x squared. Okay, and then plus x. This x transferred to the right side become minus x and minus 1. So 0 equals to x squared minus 1. Okay, so we're going to locate the x coordinate from this one. So 0 equals x squared equals to 1. So x actually equals to positive and negative 1. Okay, so that is the intersection coordinate, okay, of your x between these 2 curves. Okay, so once we find out what is the x coordinate, next we have to find out what is the y coordinate. So when at x equals to negative 1, your y equals to, okay, so you can use either y1 or y2 to determine the y coordinate of the intersection. Okay, so I will just use y2 because it's simpler. Okay, so negative 1 minus 1, which is equals to negative 2. At x equals to positive 1, your y equals to positive 1 minus 1, which is equals to 0. Okay, so intersection point, we have 2. Okay, which is first negative 1, negative 2, and 1 and 0. Okay, so that is the intersection point. Okay, once you determine the intersection point, you can proceed to the step number 2, where you need to sketch the 2 curves on the same graph. Okay, so we have here y equals to x. Okay, y equals to x minus x squared is a quadratic function, but a negative quadratic function. So it's not a smiley, but it's a grumpy faces. Okay, so you can also determine the x-intercept from here. It should be x minus x squared. So it's x and 1, 0 and 1. Okay. Okay, so this is your y equals to x minus x squared. So it intersects at x equals to 0 and x equals to 1. Okay, next we have to sketch linear line y equals to x minus 1. Okay, so this linear line, okay, so this linear line will intersect the x-axis at x equals to 1, and it also will intersect the y-axis at negative 1. Okay, so this is y equals to x minus 2, x minus 1. Okay, so let's find out the area bounded between the curve y1 and the linear line. So these are the region that we are looking for. Okay, so the area. Okay, so once you already sketched the graph, okay, so next one, okay, we have to label the intersection point. Okay, so label the intersection points. Okay, we already determined from the first step the intersection point. So we have here first, our intersection point is at 1, 0. Okay, and another one is at, see this one, okay, negative 1 and negative 2. Okay, so that is your intersection point. Okay, so we already label the fourth step, okay, which is label the required region, and we can proceed to the final step, which is to calculate the area of the required region. Okay, so area of the required region, this one we're going to use the general formula y, okay, sorry, we're going to use the general formula area equals to integrals BA, okay, fx minus gx dx. Okay, fx minus gx dx, or y1 minus y2 dx. Okay, so this area equals to your upper limit, which is 1, the intersection coordinate 1, and then the lower limit is the intersection coordinates at a lower x values, which is negative 1. Okay, so your y1, okay, so your y1 minus y2, okay, dx, okay, which is equals to integral 1 negative 1, okay, fx minus gx close bracket dx. Then we're going to substitute 1 negative 1, okay, which is this one is x minus x square, okay, minus x minus 1, then dx. Okay, so from here we can integrate. So integrate x will become half x square minus 1 over 3 x cubed, okay, minus half x square minus x, okay, between 1 to negative 1. Okay, so next we're going to simplify. What I mean with simplify, that means I'm going to simplify the one in the square bracket. Okay, so this half x square meets negative half x square, so it will be cancelled out, so leaving us with negative 1 over 3 x cubed, and this negative meet a negative x, so it will become positive. Okay, so we have here negative 1 over 3 x cubed plus x between 1 to negative 1. Okay, so we're going to substitute when your x equals to 1, okay, is equivalent to 2 over 3, minus when your x equals to negative 1, it becomes negative 2 over 3. So in total, 2 over 3 negative, okay, minus negative, so it becomes positive. So final answer is 4 over 3 unit square. Or you can also convert it into decimal places. So that is the final answers for example 4. Okay, so let's move to the final examples of this video, which is example 5. Okay, so in this example 5, you were given two different functions. Okay, y equals to 6x minus x squared, and another curve is y equals to 6x minus 1. Okay, so y equals to 6 over x minus 1 is a rational function. So in this question, they give you the condition for this rational function, which is for your x greater than 0. So you don't have to draw the entire rational function, because rational function will have two parts of the curve. Okay, one is either at the positive side of the x-axis, or another one is at the negative side of your x. Okay, so since it's already mentioned it should be greater than 0, so we're going to just focus on positive part of your x. Okay, so curve y equals to 6x minus x squared and y equals to 6 per x minus 1. So first step, find the intersection points between the two curves. So we're going to equalize y1 equals to y2. So 6x minus x squared equals to 6 over x minus 1. Okay, so I'm going to multiply every terms with x, okay, because I want to cancel out this x in the denominator. So it becomes 6x squared minus x cubed equals to 6 minus x. Okay, so I'm going to rearrange. So it becomes x cubed minus 6x squared minus x. Okay, and then plus 6. Okay, so that is the final equation. X cubed minus 6x squared minus x plus 6. Okay, so from here we're going to factorize. Okay, so this one you're going to factorize. Okay, so factorize this a cubic function. You can use either using factor theorems or remainder theorem. Okay, by trial and error. Okay, one of the factors of 6. So factors of 6 can be 1, negative 1, 3, 2, either positive 2, negative 3, or negative 2, positive 3. So 6, either positive 6 or negative 6. Okay, so you can do trial and error to find out which of these numbers are the factors of 6 and which of these factors is the factors for this entire equation. Okay, I'm not going to elaborate further about this because this one already covered in your chapter 1. Okay, so I'm just going to write down the final factorized equation for this one, which is x minus 1, x plus 1, x minus 6. Okay, so from here you get your x equals to negative 1, 1 and 6. Okay, so next, when you already get the x coordinate of the intersection point, you're going to find out what is the y coordinate of the intersection point. Okay, so to determine the y, you can either use y1 or y2 to find out what is your y values, y coordinate. Okay, so I already calculate for you. So when your x and then your y, when your x equals to negative 1, your y equals to negative 7. Okay, when your x equals to 1, your y equals to 5, and when your x equals to 6, your y equals to 0. So this is the intersection coordinate or intersection point of the two curves. Okay, next we have to sketch the curve. Okay, so we have a combination of quadratic function as well as a reciprocal function, or sometimes we refer it as a rational function. Okay, so let's draw. So this is your x-axis, this is your y-axis. Okay, so the x-intercept of your y1, okay, y equals to 6x minus x squared, which this one we can simplify y equals to x 6 minus x. Okay, so from here you can find out what is the x-intercept, which is 0 and 6. Okay, so 0 and 6. Okay, so this is the 0 and this is 6. Okay, so this is for your y equals to 6. Okay, 6x minus x squared. So that is the first one. Okay, so next we're going to sketch the curve of y equals to 6 over x minus 1. Okay, so we already know that the condition applied here is x greater than 0. So we're going to ignore this negative 1 and the intersection point at x equals to -1 and at y equals to -7. We're just only going to focus on these two intersection coordinate, which is at x equals to 1 and at x equals to 6. Okay, so there are intersection between the two curve at x equals to 1. So let's say this is your at x equals to 1 and another one is at your x equals to 6. Okay, so let's say this is 5. Okay, so that is the coordinate intersection between the two curve. Okay, so this is your y equals to 6 over x minus 1. Okay, so we're going to label the intersection points. Okay, so the first intersection point is at 1, 5, and then second intersection point is at 6, 0. Okay, so the area enclosed between these two curves is actually this region. So we're going to look for the area of this region. Okay, so area equals to integrate, okay, from 6. Okay, the upper limit should be a bigger coordinate of the intersection point, which is 6, and the lower limit is the lower values of x coordinate, which is 1. Okay, y1 minus y2 dx. Okay, which is 6, 1. Okay, so your y1 is 6x minus x squared minus, okay, 6 over x minus 1 dx. Okay, so we're going to integrate the equation. Okay, so integrate 6x, it becomes 6x squared over 2 minus x cubed over 3. Okay, minus, okay, integrate 6 over x is equivalent to integrate 6 over x. Okay, dx is actually you are integrating 6 1 over x dx, and integrating 1 over x, this is a ln function. Okay, this is ln, so you will get 6 ln x. Okay, so here is 6 ln x minus x. Okay, between 6 and 1. Okay, then we can simplify. You get this one as 3x squared minus 1 over 3 x cubed, okay, minus 6 ln x plus x between 6 to 1. Okay, it should be a square bracket for this one. Okay, then we're going to substitute. Okay, when your x equals to 6, okay, you will get the answers to be 331.249 unit square. Okay, minus, okay, when your x equals to 1, okay, which is equivalent to 11 over 3 unit square. Okay, then press your calculator to get the final answers, which is 27.58 unit square. Okay, so that is the final answers, which is the area of the shaded region. Okay, 27.58 unit square. Okay, so we are done for our today's lesson. Okay, I already showed to you several examples, 5 different examples on how to calculate the area between the curve. Okay, so we already see how to calculate the area. Okay, the area bounded by the curve with the x-axis. We have 2 different examples, example 1 and example 2. Then we meet with a third example, example 3, which is to calculate the area bounded by the curve, okay, between the curve and the y-axis. Okay, so it's slightly different from the example 1 and example 2 because you need to find out what is the function x in the terms of y first before you can substitute into the general formula and evaluate the answers and calculate the area. Okay, example 4 and example 5 is the combination area. calculation, okay, which is the area bounded by between two curves. In example 4 is between one curve and one linear function, and example 5 is between two different curves. Okay, it doesn't matter either y1 and y2 is a curve or is a linear function. Whenever you come up with this kind of question, you need to follow the guidance given here. Okay, so we have to find out what is the intersection point, okay, and then label the region of the area bounded between the two curves, and from there only you can calculate the area. Okay, so thank you for watching. I hope you guys understand about how to calculate the area using integration. Thank you for watching. Bye bye.